Here I have the Student Survey dataset from the second edition of the Lock 5 textbook. In this example, we're going to be comparing students who said that they would prefer to win an Academy Award, a Nobel Prize, and an Olympic gold medal in terms of their overall SAT scores. We'll start by checking assumptions, then we'll use Minitab Express to conduct a one-way ANOVA with Tukey pairwise comparisons, and I'll walk you through interpreting all of the Minitab Express output. To begin, we need to check assumptions. The first assumption is that we have independent groups. From this data set, we could see that each student selected either Academy, Nobel, or Olympic. So each student is in only one group, and those groups are in no way matched or paired. This assumption has been met. The second assumption is that SAT scores are approximately normally distributed in each of the three groups. To check this, we can construct a histogram or dot plot with groups. I'm going to construct histograms with groups. Our Y variable or response variable is SAT scores, and our grouping variable is award. Here we have a histogram for each of our three groups. Remember that this is a sample, so these are not going to be exactly normally distributed. We just need to look at these plots to make sure that they're not skewed or that they have any very large outliers. In this case, these distributions all look approximately normal, so this assumption has been met. The last assumption is that our population variances are equal. Again, we don't have the populations, we have samples, so to check this assumption, we're going to compare the sample standard deviations. If we scroll down here, along with our histograms with groups, we get summary statistics. So we can compare the standard deviations of these three groups. The largest standard deviation is 151.29, and the smallest standard deviation is 114.128. 151.29 divided by 114.128 gives us a ratio of 1.3256. Our largest standard deviation is not more than twice of our smallest standard deviation, so this assumption has been met. With all three assumptions met, we can go ahead to conduct our one-way analysis of variance. Under Statistics, I'll select ANOVA and one-way ANOVA, and these directions should be the same on a PC as well as a Mac. Our response variable is SAT, and our factor is award. Under Comparisons, I'll select Tukey, and we'll run our test. Minitab Express will give you a fair amount of output. We'll go through now and we'll look at each table or graph individually. The first pieces of information that Minitab Express will give you are the null and alternative hypotheses that were tested. It also states equal variances were assumed for this analysis. Now, Minitab Express is not checking this assumption for you, but is reminding you that equal variances were assumed. You still need to go and check that assumption for yourself before you run this one-way ANOVA. The next piece of information that we get is factor information. This tells us that our factor, or independent variable, was award. There were three levels, and in alphabetical order, those levels were Academy, Nobel, and Olympic. So these first two tables are really helpful if you save this information and then you go back to it later, and maybe you don't remember what tests you ran or what variables you used. Next, we have analysis of variance. This is also known as the ANOVA source table. The source of award is our between groups variation. So the degrees of freedom here is k minus 1, the number of groups minus 1. Error is our within groups variation. So here the degrees of freedom are n minus k. ADJ stands for adjusted. Though for a one-way ANOVA, nothing is being adjusted. This is just our sums of squares and our mean squares values. The F value is your F test statistic. The F test statistic is usually written along with the degrees of freedom. So here we would say F with 2 and 359 degrees of freedom equals 11.67. And then our last column is our P value. P is less than 0.0001. Here we would reject the null hypothesis. We would conclude that the group means are not all equal. Remember that an ANOVA is an omnibus test, so this just tells us that there's a difference somewhere. It doesn't tell us where the difference is. To determine where the difference is, we'll have to look at our Tukey pairwise comparison output. We'll get to that shortly. The next table that Minitab Express will give you is the model summary. We're not going to be using the model summary in this course, but really quickly, I can tell you that S is the pooled standard deviation. This is just a way of averaging the standard deviations from the three groups. And R squared is the proportion of variance explained. So the proportion of variation in SAT scores explained by students' award choices. The means table that you'll get next is just a table of descriptive statistics. So the sample size, sample mean, and sample standard deviation for each group, and an unadjusted 95% confidence interval. You should not be looking at these confidence intervals because these do not take into account that there are 3 different groups and 3 confidence intervals being computed at the same time. Instead, the confidence intervals that we're going to be paying attention to are those that come with our Tukey pairwise comparisons. Now we're moving on to our Tukey output. First, we get this grouping information table. In this table, means that do not share a letter are significantly different. In this case, Nobel only belongs in group A, and Olympic only belongs in group B. Nobel and Olympic do not share a grouping letter, so the means of these two groups are significantly different. Nobel and Academy both belong in group A. Academy and Olympic both belong in group B. So these pairs are not significantly different. The table that I prefer to use, though, is the Tukey Simultaneous Test for Difference of Means table. This gives us all of the possible pairwise comparisons, the difference in sample means, the standard error of that difference, an adjusted 95% confidence interval, a t-value, and an adjusted p-value. These are the confidence intervals and p-values that you should be looking at when you're making pairwise comparisons. These are adjusted to take into account that there are 3 different pairwise tests being performed simultaneously. To determine which groups are statistically significantly different, we can look at the adjusted p-values. In this case, the only p-value that is less than or equal to 0.05 is the Olympic-Nobel pairwise comparison. So the means of the Olympic and Nobel groups are significantly different. The means of the Nobel and Academy groups are not significantly different, and the means of the Olympic and Academy groups are not significantly different. Next, we have the graph of the Tukey simultaneous 95% confidence intervals. This is just showing you the confidence intervals from the last table. There's a line drawn through 0. If an interval does not contain 0, then the corresponding means are significantly different. This should look familiar from earlier in the semester. Remember when we looked at 95% confidence intervals and we looked to see if 0 was in the middle? If 0 is contained within a 95% confidence interval, then it is a reasonable estimate for the difference between two groups, and it's possible that they're not different from one another. In this case, again, we can see that the Olympic-Nobel confidence interval does not contain 0. Therefore, 0 is not a reasonable estimate of the difference in the populations, and these two groups are statistically significantly different. The last graph that you'll always get is the interval plot of your response variable versus your independent variable. These are the 95% confidence intervals that we saw in the earlier table. Remember, these are not adjusted to take into account that 3 confidence intervals are being computed at the same time, so we're not going to be using this graph. So to summarize our results, first, we look at the ANOVA source table. We find our F value and our P value, and we make a decision about the overall one-way ANOVA. In this case, our F value is 11.67 with 2 and 359 degrees of freedom. Our P value is less than 0.0001, so we reject the null hypothesis. There is evidence that the means of the 3 groups are not all equal. Now that we know that there is some difference, we can look at the Tukey output. My preference is to use the Tukey simultaneous test for differences in means table. We look at the adjusted p-values. In this case, the only statistically significant pairwise difference is that between the means of the Olympic and Nobel groups.